Hello and welcome to the video lecture again. In this video, I am going to describe how you can calculate specific capacitance from CV. And CV, by CV, I mean cyclic voltammetry. So here I have the data of three different cyclic voltammetries at 25 scan rate, 50 scan rate, and 75 scan rate. All of these files has been taken from a gamma ray instrument. You can take the files from a core test or whatever potential stat you have in your lab. And then what you have to do, you have to open it. You have to actually plot it in the origin. So for plotting the CV in the origin, you have to collect the current and the voltage values. So here I'm going to collect the current and voltage value. So here is the current value, and the second column is of the voltage. So I'm going to copy this one. So after copying this one, I have to go to the origin. So after going to the origin, I have to open a new workbook. So after opening the new workbook, what I have to do, I have to paste the values of the CV values that I have just copied. And then after pasting, I have to select all of these values. Then I have to go to this line plot and then plot this CV. So here, as you can see, that this is our CV curve, and I have to make it more visible, so I can increase its diameter to 2. So here is our CV curve, as you can see on the screen. Now for calculating the specific capacitance, what you have to do, you have to calculate the area of this CV curve. So for calculating the area of the CV curves, you have to go towards the analysis, and then you have to go to the mathematics, then you have to find the polygon area, then open dialog. Okay, after clicking open dialog, you have to select the absolute area. Okay, we are going to find the absolute area for this polygon. So for after that, you have to click OK. So here, as you can see, that the area that has been calculated has been marked in your graph, and then here is your area, the value for the area. You have to copy this value. This is actually the area that you are going to use to find the specific capacitance. Okay, so what's the formula for specific capacitance? So the formula for specific capacitance is the area from CV. Okay, so this is the area that you have found from CV, and you have to write its value, and then you have to divide it by 2, mass loading, scan rate, and voltage window. Okay, so we can represent area from CV as integration IVDV, and then 2 here, and then mass loading is represented by M, and then we have scan rate represented by mu, and then we have voltage window delta V. Okay, so now I'm going to plug in all the values that I have just calculated. So that would be CP is equal to, so the area was 0. I've just copied the area and then pasted it here. Okay, and now I have to divide it with 2 multiply by scan rate. So what was the scan rate? I was actually performing my readings on 25 scan rate. Similarly, these readings that I took, this CV that I took was on 25 scan rate, but it was 25 millivolt per second. Okay, the scan rate is equal to 25 millivolt per second. So the scan rate was 25 millivolt per second. So I have to convert the millivolt into volt per second. So for converting the millivolt into volt per second, that would be like um, scan rate is equal to 25 divided by 1000. Okay, and then that will be converted into volt per second. 0.025 volt per second. So that is the value for my scan rate. So I'm going to put it here, 0.025. The next thing we have is the mass loading. Okay, so mu was the scan rate and m is the mass loading. I know the what is the mass loading? Actually, the mass loading is the amount of the material that you have deposited on the nickel foam while performing the CV. So how can you find that? For my material, the amount of the material that I deposited on the nickel foam for testing, that was 2 milligram. Okay, so again, it is a milligram. You have to convert it into gram. Let me just write it. The mass deposition means the mass that I have deposited on the nickel foam while performing the reading was 2 milligram. So that will be equal to 2 divided by 1000, and that will convert into gram, and 2 divided by 1000 will be equal to 0.002 gram. So now I'm going to plug in the value for mass loading, that is 0.002 gram, and what I'm left with last one is the voltage window. Actually, the voltage window is the window in which you have performed the CV. So going back to our CV, I have performed the CV from 0 to 0.55. Okay, so that was the voltage window that I have put, 0 to 0.55. So in that case, my voltage window will be voltage window. You have to calculate the voltage window by subtracting the final voltage minus initial voltage. So after subtracting the final voltage minus initial voltage, that will be delta V. Okay, and delta V is equal to, since my final voltage was 0.55 volt and my initial voltage was 0 volt, and then my answer will be 0.55 volt. So this is my voltage window, and now I have to plug in the value for the voltage window here too. So that will be 0.55. So that will be 0.55. So after doing that, what I have to do, I have to just use my calculator and find the answer for this. So after calculating the value, so after plugging in all of these value in the calculator, the value that came out was 243.09, and that is in farad per gram. Okay, so this is the method of calculating the specific capacitance from CV. Now what you have to do, you have to calculate the specific capacitance from CV at different scan rates. Okay, after calculating the CV from different scan rates, you will see that there will be a difference, there will be a trend that will be followed for the material. Okay, so that is the method for calculating the specific capacitance from CV. Okay, if you have any question, you can ask me in the comments. Thank you, and see you again in the next video.